Hello, I am Nader Imani. I'm Executive Vice President of Festo Didactic and one of the godfather of Industry 4.0 competition at WorldSkills 2021 in Shanghai. I joined the movement of WorldSkills back in 1997, and I can really say that WorldSkills is the best benchmark that you can ever find in TVET worldwide. It is a kind of reflection of what really the labor market worldwide would require in terms of future jobs. We are proud together with Siemens and Festo, having had this collaboration since November 2016 to prepare the WorldSkills competition at Shanghai in Industry 4.0. We are very certain that this will reflect the kind of skill that the modern advanced manufacturing industries would require worldwide. And we are very pleased to present it and showcase it in Shanghai for the world. I hope to see you there.
My name is Sasha Simovic. I'm an electronic and IT engineer. I've been working at Festo since 2005 as technical support specialist. I'm also nominated skill competition manager for the Skill PO4, Industry 4.0 at WorldSkills Shanghai 2021. My aim is to drive Industry 4.0 skill with my expertise to the excellence in Shanghai 2021.
Hello everyone, and very much welcome. I would like to welcome all participants in this online seminar and all participants in this online seminar, Introduction to Skill PO4 Industry 4.0 as WorldSkills Shanghai 2021. The online seminar is a last of a series of 4 online seminars. This one addressed to a worldwide audience. So let me wish you all a very good morning, a good afternoon, a good evening from Oceania, Asia, Europe, Africa, and Americas. In the meantime, the fourth industrial revolution has been taking over the modern practice of manufacturing all over the world. The mass customization of manufacturing, aiming at lot size 1 production in full respect of ecology and economy, supporting an environmental friendly production with subjects such as energy efficiency, energy and waste management, as well as high productivity and production efficiency, along with digitizations of industry and the use of big data are common practice in advanced manufacturing industries. My name is Nader Imani. I am Vice President for Global Education with Festo Didactic, and I'm going to be your moderator today. In this session, I have the pleasure to introduce you to Mr. Sasha Simovic, expert in Industry 4.0 and Skill Competition Manager Industry 4.0 at WorldSkills Shanghai 2021. Also, I would like to acknowledge our cooperation with Siemens Automation Corporate with Education, SCE, which has been the framework to define skill competition in Industry 4.0 with WorldSkills International since November 2016. During the session, I would like to ask you to prepare your question in the chat. For organizational reason, we will set all participants at mute. In the second half of the sessions, together with Sasha Simovic, we will address all your questions. We will also have the following agenda as a part 1 introduction of WorldSkills Industry 4.0 for about 30 minutes, and we'll be very pleased to address your questions in the second half of the sessions for another 30 minutes. Not willing to hold you any longer, I would like to hand over the stage to Sasha for his insight on what Skill Industry 4.0 competition will be all about in Shanghai 2021. Sasha, the stage is yours.
Thank you, Nader. So, Good morning, everyone. My name is Sasha Simovic. I am a nominated Skill Competition Manager for the Skill PO4 at WorldSkills Shanghai 2021. It will make me pleasure to introduce the competition to you today. Professionally, I am an electronic and IT engineer working at Festo Didactic as technical support for sales. So let's see what is this all about. What is Industry 4.0? Nowadays, almost everyone is talking about digitalization, about Industry 4.0. But what is this at all? We may define it as the fourth industrial evolution in the production philosophy with main focus to produce different products with the same production line, to shorten the reaction time to particular customer demands, to diminish production cost saving energy, and to share information between machines and people. After mechanization in the first industrial evolution, where we had water and steam power as the power, electrification, where we introduced electrical energy in the production, robotization in 70s in last century, we are now in the era of cyber physical systems, where the machines talk to each other and make decisions autonomously. Therefore, we need a new profession. Numerous benefits are behind the digitalization. Continuous growth in all spheres of our lives for all of us. Everyone may be involved in the global supply chain process. Sustainable economic production with an accent on ecology. Industry 4.0 is a competition for industrialized, re-industrialized, and emerging markets, which creates jobs and prosperity for all of us. Integration of different IT systems on different hierarchical levels and processes are behind the information sharing. Everyone talks to each other. Everyone talks to the others. Every single machine may be talker, every single machine may be listener. What is the benefit of listening to the others? It is prevention, preparation for possible impacts in advance. I'll give you two examples from the human world and from the machine world. The first one from the human world. If I've gotten information that my kids are on playground, playing with friends, I may relax, take a rest, letting my actuators, my muscles being off. With this, I save my energy. I just leave my ear and a piece of brain listening for the information coming from my kids. The other parts of my body can relax. What does that have with the production and for the industry? The same philosophy is actually in industry, in the industrial production based on the philosophy Industry 4.0, because men made machines and the philosophy for the production. So what is the second example? Example from the machine world. We do have machines, for example, here in the production line. If I do have a machine number one, which is, let's say, this robot assembly cell, that machine is waiting for the neighbor machine, number two, to finish its operation before it starts producing something. So that machine is waiting that that machine finishes the operation, some operation on the workpiece, on the material which has to become the final product. If that machine here sends an information that it cannot work due to the fall of pressure, for example, from 6 to 2 bar, the machine number one may decide to switch off its actuators and with this to save the energy. What that means when I say communication between machines and people. In Industry 4, we do have a communication protocol between everyone, every single machine in a production, on a production line. Everyone can talk, everyone can listen. Why do I need to listen? Why do I need to talk?
That's exactly the example which I've explained before. If a machine, this one here, sends an information to all of participants that it cannot work from any reason, from that reason that I've explained, for example, the pressure was fall down below the expected level, the other machines who keep their actuators ready to work, those actuators, electrical motors, cylinders, valves, etc., etc., they are all of them, they are ready to work. They are under tension. They are ready to work, so that therefore, in order to be ready to work, they have to consume the energy to be ready to work. In this case, if that machine here is waiting a working piece coming to the right side, and that machine sends the information to the others that it cannot work, that machine here can hear the message, can switch off all actuators, and with this to save energy for the owner of the company, so for the company to save, not to consume energy for nothing. This kind of thing is actually called sharing of information, what I've mentioned a few moments ago. A few moments ago, I've mentioned that everyone may be involved in a global supply chain process. The name of this feature is actually horizontal integration. Everyone may be supplier, producer, or consumer, or a client. As you can see, this is actually the horizontal integration. So, on the top of the sharing of information between members in the supply chain, which is one of the core points of the philosophy Industry 4.0, provides all of them relevant facts without any delay, allowing them to shorten their reaction time. What that means? You do have, in Industry 4.0, you do have communication way, direct communication way between the production cell or production plant, the supply chain or the manufacturers of the raw material, and the clients at the end. In practice, for example, you do have here a storage. It looks like a drilling machine, but let's say this is a storage machine. So having material in the storage. You do have a sensor, for example, which gives you an information when you have less or 10% or less than 10% of the raw material. That sensor, so in the storage, that sensor will send an information to all of participants in the connection, in the network, saying that the storage is almost empty. That information in Industry 4 will be also transmitted to the manufacturer of that material. So no one needs to give a call from the production line, from the shop floor, to someone at a supply chain, so on the manufacturer of the raw material, and then to deliver the raw material to the production plant. The information will be sent automatically, and someone, an employee of the manufacturer of that raw material, will get, for example, either an email or a chat info, WhatsApp, Viber, any communication application that the storage has to be fulfilled. So in that case, so there is no delay in that exchange of information, and the manufacturer will send a truck to supply the storage with the information. On the other side, the customer may receive an information from the production plant what's going on with his product and when can he expect to get his product ready. So in this case, we use IT technology, so we use information technologies to connect all of them in a line, exchanging the information, getting an information without any delay. The same concept of sharing information between customers and shop floor or here is actually called vertical integration. You may have, for example, a website of festo.com. You may order your product. When you click on the button send, this send will transmit your wish, what you would like to get, through ERP and MES software. The MES software will issue a direct command to the appropriate machines in the line to produce a product without any delay. So this is actually called vertical integration. Or when you have an employee operating on a machine, let's say we do have automatized production process, and that's fine, but there are still, or an engineer of production may decide to define the working places where the manpower is needed, where an employee may use his hands and fingers to do something. That person can be sick, can be ill, can be absent from the working position, can be on vacation. So that information is actually sent from shop floor to the ERP, Enterprise Resource Planning. An employee is a resource of a company. So communication between the software, the production software, manufacturing execution software, or ERP and the shop floor, and also for the communication to the customers, to the order process, is actually called vertical integration. Production philosophy Industry 4.0 is consisted out of 43 core elements. You do have, or the philosophy Industry 4.0 does have 43 different names, different bricks, if I may say. If you want to build up a house called Industry 4.0, you do have 43 different elements which consist of in the philosophy Industry 4.0. I'm sure you have heard for some of them. RFID, Internet of Things, smart maintenance. All of them do impact the future industry practices in product design and in the production processes. On the left side, we may see how German Machinery and Plant Manufacturing Association defined the steps to upgrade product design and the production processes from the Industry 3 level to Industry 4 level. On the right side, two young colleagues of mine applies smart devices, tablets, for smart maintenance in practical manner in the production plant at Festo. So you may have it here. Smart maintenance means you use a smart device, tablet, mobile phone, you approach a machine, you establish a communication with the machine, and the machine tells you what is the problem with the machine. As I mentioned, the philosophy Industry 4.0, production philosophy Industry 4.0 is consisted out of 43 core elements. Here they are: cyber physical systems, radio frequency identification, near field communication, digital product memory, machine-machine communication, man-machine interaction, man-robot collaboration, assisted operator, mobile robotics, energy efficiency monitoring, renewable energy integration, smart or mobile maintenance, condition monitoring, augmented reality, virtual reality, QR code, bionics, reconfigurable factory, batch size 1 or lot size 1, plug and produce, shop floor management Industry 4.0, lean management, digital twin, digital shadow, horizontal and vertical integration, pick by light or put to light, data security, OPC UA, communication protocol which I mentioned before, which is used on the production line for everyone to exchange the information between themselves. Internet of Things or Industrial Internet of Things, real-time communication, big data, 3D printing, cloud computing, blockchain, enterprise resource planning, manufacturing execution system, supplier relationship, intelligent logistics, customer relationship, WWW, World Wide Web, smart devices, smart machine, smart factory. The competitors in the competition Industry 4.0 are, and the future technicians need to know and understand the meaning of core elements Industry 4.0. To know, so to understand all of them, all 43 core elements. To know their own strengths and limitations. To know standards and protocols for technical communication in English, in electronic form, in cyberspace, and to be able to document what they have done in paper and electronic form. The new job profile for this will be named Digital Production Systems Technician. Important thing to say, Digital Production System Technicians has to know all 43 core elements and to be able to understand them and to act if act accordingly on the shop floor, on the production line, if he or she meets such a feature of a machine. The main sections of WorldSkills standard specification listed in technical description of the competition in Industry 4.0 in the holy book of the competition itself, where the competition is described. In fact, work organization and management, communication and interpersonal skills, design, assembly and commissioning, software design and implementation, networking and cybersecurity, testing, maintenance and fault finding, enhancement and optimization, analysis, evaluation and reporting are to be implemented in 4 days competition. On the right side, you may see the initial format for the Future Skills Competition Industry 4.0 at WorldSkills Kazan 2019. As you can see, we had 4 days. During the morning and afternoon, we touched those parts of 43 core elements. So it was the very first unofficial, so general probe competition before the Industry 4.0 became official one. The history of development of the skill Industry 4.0 began during the WorldSkills General Assembly in Niagara Falls in 2016 with initial discussions which were roughly defined in the first concept idea which was presented at the WorldSkills Abu Dhabi in 2017. So the idea of competition Industry 4.0 was born actually during the WorldSkills General Assembly in Niagara Falls in Canada. That concept and why that competition is important was actually presented officially during the WorldSkills Abu Dhabi 2017. The training camp as the very first trial competition took place during EuroSkills 2018 in Budapest, with participation of 4 countries, Austria, Germany, Hungary, and Russia. The concept was redefined during the WorldSkills General Assembly in Amsterdam the same year. Future Skills Competition Industry 4.0 was an unofficial WorldSkills competition, but under the already developed technical description at the WorldSkills Kazan 2019 with the participation of 5 countries, Austria, China, Germany, Russia, and the Netherlands. What is planned? Due to the COVID-19 pandemic, postponed EuroSkills Graz 2020 to January 2021, the competition will be HP2, that means host presentation skill, and then at WorldSkills Shanghai 2021, the very first official one. The competition team should be consisted of one participant knowing mechatronics, mechanics, electrotechnics, automation technology, and a computer science or an IT technician, not older than 25 years in the year of the competition. So nowadays we still do not have digital production systems technician combining mechatronics or mechanics, electrical engineering and IT. So therefore we need two guys, so two competitors, one knowing more mechatronics, mechanics, and someone else knowing more deeply the IT technology. The competitors could be selected from colleges, vocational education and training institutions, companies or industry bodies, as the Chamber of Commerce or so, following educational system in respective countries. Some of people do have an impression that the skill Industry 4.0 is the same or very similar to the skill mechatronics. That's not true. In the skill mechatronics, competitors assemble mechanical and electrical components in a system and programming them with a PLC in order to make a system able to perform an operation and or to produce a product. Always the same product. So that means you do have pneumatic components, you have electrical components, you have a PLC as the brain of a system. Mechatronic technician assembles everything, fix everything, that everything runs well, connect them, and then operate or manage the input signals to give the output signals from the PLC to make a movement or to make a production of a product, but always the same product. In the skill Industry 4.0, competitors use mechatronic systems as the base and implement core elements Industry 4.0 on the top of it, making the system more effective, optimized, cost-saving, production diverse, secured, smart. What that means in practice. You may observe mechatronic system as the ground floor of a house. So someone, a future digital production system technician, has to know how mechatronic system runs, has to know how to react if, for example, a pressure in a machine drops to 2 bar or drops to 0. So has to understand how to fix the problem with air drop. Or if the system does not have power supply, either 24 volts or 230 volts, he has to know how to measure the voltage and to find out why the system is stopped. So this is knowledge of mechatronics. Industry 4.0 are the characteristics which sits on the top of a mechatronic system. So it's not a competition between two of them. It's a competition on the top of knowledge of a mechatronic system. Skill mechatronics or mechatronics combines skills in mechanics, pneumatics, hydraulics, electrics or electronics, robotics, PLC and robot programming, connectivity between machines and systems, needed for system development. Mechatronic technician design, build, commission, program the PLC and HMI, ensure the data flow between the peripherals and the PLCs, maintain, repair and adjust an automated industrial system. When I say here ensure the data flow between peripherals, you may have peripherals, inputs and outputs, so sensors and actuators. You may have sensors, for example, who are connected directly to a PLC via cables. You may have peripherals which are connected to the PLC via field bus, for example, CC-Link, Ethernet IP, DeviceNet, Profibus, Profinet, CAN Open. So all of those, that knowledge is actually something which mechatronic technician has to know. So how to ensure the data flow between input and output components to a PLC. Industry 4.0 combines skills in fundamentals of mechatronics, so to know how mechatronic system runs. Combine skills in software development, the web development, cloud or edge computing, virtual or augmented or augmented reality applications, networking and security, industrial Internet of Things, condition monitoring, smart maintenance, optimization, communication between production and people, and bionics needed for systems development or enhancement of an existing mechatronic system. So those skills, someone has to know how to operate with the mechatronic system, being able to implement on the top of that system those features, as I mentioned here, to enhance an existing mechatronic system. How many machines do we have nowadays in the world running on the Industry 3.0? So there are billions of them, maybe even more. So the manufacturers do have two options: to throw out all of those machines and to buy completely new Industry 4.0 machines, which is nice investment, or they have an option to enhance, to improve the existing machines from the level 3 to the level 4. So how to do it? Industry 3.0 machine is a mechatronic system producing one single product all the time. You may have that digital production system technician has to be able to understand the business cases for the enhancement from the level 3 to level 4. So that means he has to understand how the machine runs and how he or she could implement one or more or all of 43 core elements in order to improve the machine Industry 3.0 to the machine Industry 4.0. Therefore, that system technician designs and implement technical responses accordingly based on core elements of Industry 4.0 production philosophy. That's exactly what I've mentioned. They have to understand how to improve the machine, and they have to know how to implement core elements on the top of mechatronic system in order to make the system Industry 4.0. The digital production system technician develop software solutions for data access, assembly, commission, and maintenance. Ensures safe data transmission among production systems and people, is able to mass customize the production, test, maintain, fault find, and optimize, analyze, evaluate, and report possible changes on an existing mechatronic industrial system. That means when I say develop software solutions for data access, assembly, etc., etc., now is the time to clarify or to explain you the what we have previewed as the knowledge of that production system technician. Imagine you have a technician knowing fundamentals of mechatronics and then have knowledge of all 43 core elements. It's a nice amount of knowledge. So we expect that the digital production system technicians knows all 43 core elements on a basic level, because it's a bit too optimistic to expect that a technician knows everything, all features until the last point. So, I mean, technology is too wide implemented in these 43 core elements that we cannot expect that a technician knows all elements until the last point. They can serve as the home doctor. So when you are sick, for example, you go and say, I have a problem with my gorge or with my lungs or so. The home doctor can give you either the medicine for this, so can resolve the basic problem, or can give you a piece of paper, can send you to the specialist to the specialist to something. So for example, if we have a skill cloud computing, for example, at WorldSkills International, that is competition in cloud computing only. Cloud computing is one of 43 core elements. So they have compete until the last point of that technology. Industry 4.0 is the knowledge of all of them on the basic level. Therefore, develop software solutions for data access, assembly, commission, and maintenance in that competition that we introduce today is actually the basic solution to improve the machine from Industry 3 to Industry 4. Ensure safe data transmission. An example, you have a production plant in Shanghai or in Jinan. The headquarters is in Beijing. The general manager of the company in Beijing would like to, or production, whatever, technical director, would like to know how many pieces does this production plant in Jinan produced in last 24 hours. If that person sits in headquarters in Beijing and the production plant is in Jinan, we have to somehow get to that information from the production plant. How to get it? Over internet. On internet, there are hackers. There are guys who, well, maybe hack the information, or competitors can get the information about your production figures or process, etc. So you have to ensure that the data exchange is secured, is scrambled, is encrypted. Therefore, the technician has to know how to encrypt and decrypt the data between two or more points. The competition material that we use, that we would like to recommend for that competition, Industry 4.0, is shown on the following two slides. We do have the single workstation, which is, as here mentioned, recommended for the WorldSkills Shanghai 2021. The second one is also recommended, but what is the differences? This is the very base system. So that system that you can see on that slide will be used in Shanghai 2021 for the competition. What is this actually? What do we have there? We have a cyber-physical laboratory module iDrill with HMI. What that means? Our Festo learning systems are actually the diminished machines to explain a process. What that means? You may have, for example, we do have here a learning system for drilling. You have a student who does not know what the drilling is, how the drill machine runs. In the reality, drilling machine can be enormously big. For learning processes, in order to understand what is drilling, actually, what is drilling all about, you don't need a big machine. You need a learning system, a compact learning system explaining the process. Therefore, we do have a conveyor with the application on the top, which is drilling machine with an HMI. Inside, we have Siemens PLC. Here we have Festo PLC, we have HMI and the system which can explain the process. Then we have the set of workpieces. So a carrier of the raw material running on the conveyor. We have NetLab twin package. The learning system, or the two learning systems to simulate the data encryption. So this is, as I mentioned, you do have one encryptor on the side of the production of the headquarters in Beijing of that company, and you do have the second one, which is decryptor, on the side of the production plant. So these two modules are responsible to scramble the data and to pack it in a non-logical way for hackers. Then we have energy measuring system with monitoring package. This is that system here. This system offers us to measure the electrical energy consumption and the air consumption. Based on the information going through the sensors of Festo and the measuring unit for the electrical energy of Siemens, we use Festo PLC to be an OPC UA server. So a member of a production line, in the production line, to broadcast the information about the consumption of air consumption and the electrical energy at that moment. Then we have a smart sensors package. As I mentioned before, enhancement of an existing Industry 3.0 machine. Smart sensors, I'm sure you know what that means. So you have a sensor to give you an information, true, false for the digital, or analog to give you an analog value. These are the very basic ones. Smart sensors do have the same main functionality, but also some features which can be used to parameterize them, to give you this information, an additional information which could help the system and the user of the system to understand, to maintain the system on the smart way. So that training package is delivered from Festo, which explains different sensors and how to implement them on the existing or the new, of course, machine. So that means how to implement them on a system. We have so-called CPX Internet of Things gateway. This one here. Why do we need that gateway? What is this? This is an interpreter between OPC UA and internet or cloud. On the level of the machine level, on the data exchange level, we use OPC UA as the protocol which understands all machine Industry 4.0 production plant. That protocol is real time. So in the specific period of time, you may send a request and you may expect an answer. If you want to publish an information to a cloud, so to send it to a service or to a web portal or to an app, then you need to switch to pack the data, the process data which you would like to publish, to another protocol, which is AMQP or MQTT. There are two protocols to send the process data information to cloud. This piece of hardware is actually the interpreter between two of them. Software MES4, the simulation, the learning software for the manufacturing execution system to operate, so to define the production. Cyrus software for digital twin and digital shadow. TIA portal software to program PLC of Siemens, and a PC with monitor to install MES4. This is the package which I recommend as a skill competition manager for the competition in Shanghai. That system here is actually extension of the system that I have mentioned before. The only difference is we have three additional learning systems for three different operations: magazine for storage, measuring module, and an output module. Why 4? Because if you want to prepare your team, the basic system is the system that I've explained, and now we do have three additional machines where you can simulate a production process in a factory. You may use this system to to explain more, to cover more core elements than only the single machine which was presented before. The Skill Industry 4.0 was empowered by two companies, Festo Didactic and Siemens. We are ready to help you to prepare your teams for the competition in Shanghai 2021.
All right. Thank you very much, Sasha, for having you on this online seminar. It has been a pleasure for me to work with you and also to bring a little bit more enlightenment on what we are planning for WorldSkills competition in Shanghai 2021. So I would just say, see you soon. See you in Shanghai.
See you in Shanghai.